7-6, lesson 79, Joel and JoJo. We're going to get practical with these shapes that we talked about last time, these quadrilateral, these four-sided beasts. And now we're going to do something a little more practical with them. We're going to learn how to find the area of a parallelogram. Remember, a parallelogram has four sides. It's a quadrilateral. And it has two pairs of parallel sides. Right? It includes things, different types. It includes a rhombus, which is all sides are. It has a rectangle, which is when the corners are squared. Right? A rhombus is like this. Kind of a diamond with equal sides. And then the third one is a square. And that's where all four sides are equal. So there's all kinds of relationships between these. Right now, the main thing I want you to remember is that these three are all types of parallelograms. So here's the way, and the best way I can explain a parallelogram to you. Do you know when you were a kid and you would play with big cardboard boxes? I know you did. I did too. It's super fun. And when you would start out, a lot of times you would open the flaps on the top and the bottom. And you would create a tunnel that you could crawl through or slither through or throw things through. So I'm going to make it three-dimensional for this picture, right? So you opened it up so that you could through it, right, and come out the other side. And when you first started playing with it, the mouth of the box probably looked pretty square, right? This area here. It probably looked like a good square or a rectangle, depending on what shape your box was, but it was even. But as you played more and more, it always gets squished. It always gets squished, you guys. I used to get so upset with my brothers because they would be really rough, and what would happen is that our perfectly square box would start to get tipped, right? This would get squishy. Pretend it's perfect, right? Because everyone had been crawling through it so much, and it was no longer big and open anymore. It was squished. This is the way I imagine a parallelogram forming. Okay? John tries to help us understand this by laying out this activity in the book that we're going to skip. We're not going to do it. But basically, he's trying to help you understand that if you take this and you squish it, by sending I have three brothers, by sending them hurtling through it, it will squish this. And if you'll imagine the area, pretend that this is the same box. I drew this one way smaller. But the area is going to change. As the box gets smushed, this area is going to be smaller. So the question is, how do we find the area of a parallelogram? Well, we can't, like I just said, we can't take the square that it used to be and find the area of that. This is different. So here's how we find the area of a parallelogram. We multiply the base times the height. Now I'm going to use a different color to illustrate what I mean by both of those so that you understand. Did you hear my zipper? It's really loud. Okay. The base is the easy part. This is the base, right? That is the base. It's just the part that's on the bottom. No big deal. The part that is more interesting and complicated is what we mean by the height. Because the height is not either of these sides. The height is if a spider climbed to the highest point on the parallelogram and dropped a perfectly straight web down. Look, there's a circle right on my page where I want to draw my spider. Spiders show up a lot in geometry, which is really nice of them because they're helpful. This is the height of the parallelogram. It is not the length of the side. It is the distance from the top to the bottom straight down. The spider could also climb here because all of this is the same height, and the height could be measured inside the shape of the parallelogram. That's fine, as long as he's at the highest point. My spiders only have 6 legs. If they have 8, I think they look too cluttery. See? That's too much. But I'm just going to do it. for science sake. Okay, so the height is straight up and down, and if you look in the book, I'll draw a picture of it so you don't have to actually look. This is the only example for this lesson, example 79.1. It says find the area of this parallelogram, and then they draw a parallelogram, and this is the parallelogram before my brothers go through the box too many times. It's tipped, but it's only a little tipped. And this is how John labels it. 5.2 centimeters here, 6 centimeters here, and then he draws something like this, and he writes 5 centimeters there. Okay, John is trying to trick us. Well, he's letting us trick ourselves if we want to. We know that we need to find, excuse me, this puffy cloud of knowledge needs to come through. We need to find the area, we need the base times the height. Okay, the base is easy. The base equals 6. The height, and this is where we have to be careful, is it 5.2 or is it 5? Oh, the spider goes up to the top, he drops his line straight down. This is not straight down, that's at an angle. So, no, we're not having you 5.2 centimeters. This is the correct height, because it goes straight down and makes a right angle with the base. So we multiply, to find our area, we multiply 6 times 5, and we get 30, and the way we write this is centimeters squared, because these are each centimeters. You don't have to keep writing the unit as you do the calculation. You'll see it in the beginning, and then just add it on here at the end, and that's fine. You don't have to keep saying centimeters as you do your work, because that would be annoying, and we don't need to annoy you. Okay, so the practice problems look pretty much exactly like this. Let me show you. Here's the parallelogram in this one, and here's where the spider drops straight down. So ignore the trick, because this side is not the height. This is the height, and this is the base. And then over here, the spider, we can see, dropped the web down inside the parallelogram. That's fine, as long as it goes straight down. We know that this is the base, this is the height, and this is just a tricky piece of additional information that you don't need. Oh, John, we are so far ahead of you. All right, that is lesson 79. Good luck, my friends. See you in lesson 80.